So as I mentioned before, PV equals nRT must be memorized. I've decided to simplify this, and instead of using the proper SI units, just using decimeters cubed and kilopascals, because they actually cancel each other out. Because one you need to times by 1,000, and to get to meters cubed you actually need to divide by 1,000 or vice versa. And so the units are kilopascals, kelvins, and that's the ideal gas constant from your data booklet. With the ideal gas laws, you just cancel out, you just keep what you're looking for. So a question could actually have all three and keep n the same, or it might have n, and then that would be your equation to use. Or it might ask you for n and v, or it could ask you for anything. So you basically, because that's a constant, you can rearrange that to PV on NT. And so in situation 1 is the same as in situation 2. And so you get this down here, and then you just cross out things that are the same to get the particular equation for the question that you're trying to do. And so for ratios, because there is a similar timesing going on for some of these things, the units can cancel each other out. But it's always good practice to go to Kelvin, because if you're using a PV equals nRT, you might get caught out because you haven't converted to Kelvin, and the mark scheme might actually give you a point for changing it to Kelvin, regardless if it was needed or not. So just a few quick examples here. So this is a pressure volume question if you read it. So there's 3 atmospheres goes to 1 atmosphere. What's the volume change going to be? So you sub those in, and then you'll simply get 6 centimeters cubed. The big question is, how did I get that equation? PV equals nRT. And so that's always constant. And so you have R equals PV on NT for the one situation, equals PV on NT for the second situation, constant number of moles, volume, constant temperature, and then that's not right. So that's our equation, so that's how we get it. Okay, another question. So this one here is a PV equals nRT question, so make sure you do this for sure. I've simplified this PowerPoint and not given metric units. I'm just going to keep it as it is. This is the one equation that's very difficult. Probably the most difficult thing to insert into Unit 3 or 4 out of all the Unit 1 material. And I don't often even see it in tests, to be honest. So it's not going to come up in your Year 12 most likely. And so just find the relevant parts of this and substitute it in, and you'll get this answer. All right, so the only real trick is memorizing PV equals nRT, so you know what the formula is that you need to substitute things into, and that's from your data booklet. All right, hope that was helpful.